Welcome to day 14 of our object-oriented programming course. Today we will recap key concepts from week 2 followed by a quiz, a coding exercise and a group discussion. Let's get started. Today's objective is to reinforce what we have learned in week 2, focusing on core OOP concepts. We will cover inheritance, method overriding, abstraction, polymorphism and composition. After the recap, you will have a quiz to test your understanding, a coding exercise to put your skills to practice, and an opportunity for a group discussion to clarify any doubts. Let's begin with a quick recap of the key concepts we have covered so far in week 2. Inheritance. The ability to create new classes based on existing ones, allowing for code reuse and extension of functionality. Method overriding, changing the behavior of methods in a derived class. Abstraction, hiding unnecessary details and exposing only the essential features of an object. Polymorphism, the ability to call the same method on different objects, each responding in their own way. Composition, a design principle where a class contains references to objects of other classes, representing a has-a relationship. Let's dive into inheritance. In OOP, inheritance allows you to create new classes based on existing ones. For example, a manager class can inherit from an employee class, reusing its functionality while adding new behavior. There are different types of inheritance like single, multi-level, and hierarchical inheritance, which enable you to organize and extend your classes efficiently. Next, we have method overriding and the super keyword. Method overriding allows a derived class to provide its own implementation of a method that is already defined in the base class. Using the super keyword, we can call methods from the parent class, enabling us to extend or modify the inherited behavior. For example, a car class might override a start method from the vehicle class to include specific functionality. Moving on to abstraction, which involves hiding the complex implementation details of a class while exposing only the necessary information. An abstract class in OOP provides a blueprint for other classes, defining methods that must be implemented by derived classes. For example, a payment class would define a method for processing payments, while different payment methods like credit card or PayPal implement their own version of the method. Now let's discuss polymorphism. Polymorphism allows objects to respond to the same method in different ways, making your code more flexible and reusable. There are two types: compile-time polymorphism, which includes method overloading, and runtime polymorphism, which involves method overriding. This concept is essential for writing clean and scalable code. Next, we will talk about composition versus inheritance. Composition involves creating objects that contain other objects representing a has-a relationship. It's often preferred over inheritance when you need to avoid tight coupling between classes. For instance, a library class might contain a collection of book objects rather than inheriting from the book class. Composition is a powerful tool for building flexible systems. It's quiz time. Let's test your knowledge on the concepts we have covered. Question 1. Which of the following best defines inheritance in OOP? A way to protect data, a method of creating new classes from existing ones, a mechanism to execute methods, a way to represent real-world objects. Question 2. What does method overriding allow in OOP? Modifying the base class constructor, changing the method behavior in a derived class, calling methods from multiple classes, and D. None of the above. Now it's time for a coding exercise. Your task is to create a class hierarchy for shapes, starting with an abstract shape class and adding derived classes like circle and rectangle. Each class should implement its own version of the draw method. Use polymorphism to call the draw method on different shape objects. This will give you a chance to apply inheritance, method overriding, and polymorphism. Let's pause for a group discussion and Q&A. If you have any questions about the quiz or the coding exercise, now it is the time to ask. We will go over any concepts that need clarification and share any insights or challenges you encounter. This is a great opportunity to discuss and deepen your understanding. Before we wrap up, let's do a final recap. Inheritance allows us to create new classes based on existing ones. Method overriding lets us change method behavior in derived classes. Abstraction simplifies complex systems by hiding unnecessary details. Polymorphism lets us use the same method in different ways. Composition provides a flexible alternative to inheritance for creating relationships between objects. Remember, mastering these concepts will give you a solid foundation for writing modular, reusable, and scalable code in any OOP language. For further learning, here are some excellent resources. Books like Design Patterns and Refactoring can help you dive deeper into OOP. Online platforms like LeetCode, HackerRank, and CodeWars are great for practicing your skills. Websites like Tutorials Point and Geeks for Geeks offer in-depth articles on OOP concepts. Keep exploring these resources to continue improving your understanding of OOP. Lastly, here's an optional assignment. Design a class hierarchy for a school management system with classes like person, teacher, student, and course. Implement inheritance, polymorphism, and composition in your design. This will give you hands-on experience in applying all the OOP concepts we have covered.